we're really happy to have you here. So we'll get started. It's a great pleasure to introduce Professor Matthew Hayek from New York University, NYU. He's doing some of the really cutting edge research in the way the food system is moving the needle, either right or wrong, in terms of climate impacts. And I was just mentioning that I had a chance to review some of his papers on Google Scholar, and it's just the topics and the titles are so stimulating and so relevant to this conference. So I just want to thank Nina Gaiman again for bringing Matthew to us today. And without further ado, Professor Hayek.
Thanks so much, Will. I really appreciate the gracious introduction, and so encouraged, I was saying from the beginning of the session, to see how much is being integrated across this session. So I'm going to go ahead and share my screen right now. And can we see it? Can we see my kind of keynote presentation here? All good? Okay, fantastic. So I'm going to be talking about reducing climate emissions from food. We've had such a diverse array of perspectives today on the issue of sustainability, but one major issue with trying to understand and pinpoint what sustainable food systems consist of is that sustainability encompasses so many different dimensions, from the physical environment to social systems. So I'm going to try to narrow it down a bit for today and talk predominantly, but not exclusively, about climate change. And my experience with climate change and ecosystems more broadly has been pretty expansive. During most of my PhD dissertation years, I had the privilege of researching greenhouse gas fluxes from an old growth Amazon forest in the eastern Amazon of Brazil. That was called the Tapajós National Forest, shown here on the map with that little dot, TNF. And we set up previous colleagues of mine set up a 200-foot tall tower above the rainforest, where I got to install instrumentation where we measured temperature, fluxes of water, and greenhouse gases into and out of that ecosystem, as well as its overall health. What we wanted to understand, and as you can see on this map from the yellow, this forest was on the so-called dry edge of evergreen Amazon rainforest. By dry, I mean it only got about 6 feet of rainfall a year, compared to other places that get 12 or more feet in the Amazon. So what that allowed us to do is understand the sensitivity of that forest to anomalously wet or dry years. But now I want to show a map more zoomed in to where this region was located. And this is here in the Tapajós National Forest, which is this triangle of green that you see bordered between Highway 163 on the right and the Tapajós River on the left. That trapezoid of forest area is about almost the size of the state of Delaware. And we would drive in, coming from the city in the north to the forest on our right, and all to the left would be these large cleared pastures. And you can see them on the map as these fishbone perpendicular scars coming out of the highways, which is the characteristic pattern of tropical deforestation, as people make further and further, carve out further and further parcels out from the road on the Amazon frontier. I originally thought that a lot of this was due to logging, as I would see trucks with big mahogany logs coming out of these dirt roads occasionally. It was only until later that I realized that 95% of this was to produce cheap beef, and it was vast land clearing due to cattle's relatively large land use requirement and the growing appetite both in Brazil, China, and elsewhere for inexpensive meat. So today, I'm going to be talking about how we can reverse some of these trends, both domestically and globally, with respect to the environment and animals in the food system. And it amounts to reducing our food's carbon footprint. But I think this story is not exactly productive if we're talking about plant futures, if we're talking about climate change, which are really global problems and institutional problems that are far larger than the individual. So in the second part of this, I'm going to be talking about scalable solutions, creating initiatives from local to global. As the biggest scale primer that I can think of, global food systems contribute about 1/4 of greenhouse gas emissions. There should be a big asterisk on this number because there was a lot of imprecision with respect to food systems. It's not as easy to quantify as burning oil, because you can count literally every barrel that's coming out of the ground and being traded. So there's big uncertainty in this overall estimate, but it's approximately 1/4. And here we can see on the left-hand bar comparing all of food emissions to non-food emissions, which are 74% roughly of all other emissions. And if we zoom in on food's contribution, we can see that it's not just in the processing and supply chain and the fossil fuels that are being burnt in blue, but rather crop production and the nitrous oxide that's coming out of fields when we apply fertilizer and manure to them. It's livestock and fish farms, which include methane from cattle belches and from stagnant aquaculture ponds. And it's from the land use that I was talking about in the Brazilian Amazon and elsewhere, where we're clearing land to make room for more resource extensive foods. Something that I think is notable about this figure is that we often talk about the merits of local food and having hyper-local foodways. And while that certainly has benefits for a local, more robust local food economy that can put put money more directly into the hands of food producers, it's not a real big slice of the pie with respect to emissions. Globally, our transportation of food only adds up to about 6% of total food emissions. And keep in mind that much of that is just transporting resources between farms. And on that second note, that what we eat tends to be far more important with respect to greenhouse gases, water use, and land use than how it's produced. You can see a wide range of greenhouse gas emissions from different food products in this graph here, all the way up from beef on that top selection down to soy milk, root vegetables, apples, and nuts all the way down at the bottom. Nuts which actually sequester a fair amount of carbon in their orchards. And while there's been a lot of press, especially in California, that almonds use a massive amount of water, and I'm certainly not going to counter that, the same analysis showed that dairy milk in developed countries on average uses twice the amount of water that almond milk does. So there's a lot of interesting things that you can kind of pull apart with this graph and dissect. You have some tropical commodities like chocolate, coffee, and palm oil, especially ones that are associated with large land clearing because those markets are expansive, resulting in a ton of emissions. But largely, the main kind of difference between these two categories is beef and lamb way up at the top, and predominantly up at the top with the highest emissions, you have animal source foods, and the lower emissions, you have plant-based foods and plant proteins. So what this amounts to is that farmed animals, despite contributing about 1/5 of global calories and 1/3 of global protein, contribute the vast majority of greenhouse gas emissions and use the vast majority of land that food systems use. Farmed animals and their resource needs contribute about 16% of global greenhouse gas emission, and this is from the most recent numbers of the United Nations reflecting a base year of 2010. Additionally, we have this major issue in the food system of 1/3 of our food being wasted. This number is roughly the same from developed contexts and developing countries, but in developed countries like most of the food waste is wasted at the consumer and retail end, whereas developing countries, India being one case in point, a lot of food is being wasted from insufficient storage, poor refrigeration, and grain mills that attract mold and pests, or rather grain silos that do. And so a lot of the same amount of food is being wasted across a lot of countries, but for different reasons. And as tragic as this food waste issue is, there is also food waste in animal supply chains if you define food waste as calories or proteins or nutrients lost in the course of producing animal-sourced foods. 44% of the world's edible food crops are fed to animals, and that doesn't even account all the pastures, forages, and minerals that are fed in a supplementary manner to a lot of different animals. Well, why is that? It all has to do with ecological or trophic efficiency. Some of the most efficient meat out there is poultry meat, or some of the most efficient animal agriculture, and that still takes on average about 9 calories of human edible grain to produce 1 calorie of chicken. And that the reason that is because ecological efficiency says that approximately 9/10 of the energy that an organism consumes are wasted as heat, urine, and feces. But what about producing our food in a different way that doesn't rely predominantly on human edible food? Well, it turns out that turning the USA's feedlot raised beef entirely to grass-fed would actually lead to needing 30% more cattle in the US. Those cattle producing 43% more methane and requiring 270% more land because of the relative lack of efficiency of eating only grain and producing much more methane in the process. So it turns out it's not just the how, it is the cow itself. And we quantified this in a 2018 paper in Environmental Research Letters. This mirrors findings from a regeneratively grazed ranch in Georgia that many of you may have heard of, including seeing the press release 2 years ago around this farm being carbon negative. A very recent peer-reviewed analysis of emissions and sequestration on that farm found that this ranch is actually a net emission source. While there were fewer net emissions than conventional beef, that advantage is likely not permanent because the soil, in sucking up carbon out of the atmosphere at this regenerative ranch, the soil cannot continue sequestering that rate of carbon forever as that soil column eventually saturates in the amount of organic matter carbon that it can have in it. And importantly, this required 2.5 times the land of conventional meat. And I'll get a little further into why that may be an issue in future slides. So in this slide, we've already discussed the fact that animals emit greenhouse gases, predominantly in the form of methane, nitrous oxide, methane in their belches, and methane and nitrous oxide in their urine and feces. But they also use a lot of land for grazing and land for the feed crops that they're required to eat. If we eat mostly plants, due to that concept of ecological efficiency, we can grow everything we need using far less land. And in the process, a lot of that land can be used, if it's in the correct ecological context, to rewild the native ecosystems that those food systems long ago or recently replaced, including many areas of temperate and tropical forests that pull CO2 out of the atmosphere in the process, meanwhile producing a nice habitat for many wild animals as a co-benefit. So in our recent study, we quantified this globally. Excuse me 1 second. Okay, so we quantified this globally in a map of this carbon opportunity cost of trimming back animal products in the human diet. And we found what many may have expected, which is that there's a large opportunity in South America around the perimeter of the Amazon rainforest for reforesting those recently deforested areas. But there are huge swaths of green as well in China and the UK and Western Europe and the Eastern Amazon, the Eastern United States, where farmland has replaced forest century to millennia ago. What we were able to do when we modeled some of these changes in dietary preferences in food systems throughout the year 2050 is we found that business as usual diets, like many studies have said in the past here on the left, are a net source that is carbon positive out to the atmosphere. But if we were to shift to Eat Lancet, which are very plant-rich diets that still have a fair amount of meat and seafood in them, or vegan diets, which is the kind of hypothetical extreme where nobody on earth was to, eat animal source food as just a kind of a test case of this modeling experiment, we found that dietary changes could suck carbon out of the atmosphere, so shown here as negative emissions, to technically sequester the past 9 to 16 years of fossil fuel emissions back into ecosystems where they were once lost long ago. We also found that the vast majority of this reforestation, rewilding potential was in high and upper middle income countries, showing that, especially in upper middle income countries that are rapidly developing, most of the opportunity cost lies in these areas. And when we compared it in high income countries to the past 10 years of their fossil fuel emissions, including the United States, shown here on the gray bar, it was roughly equal to the past decade of fossil fuel emissions. So the amount that high income countries could potentially sequester by moving towards more resource efficient food systems is very non-trivial, very significant. So that's all well and good. And this is the science that I and my colleagues have done in the past few years to show what some of the opportunity costs of shifting food production and shifting diets might consist of. But now I want to move on to stimulate a bit of a conversation at the very end here about scalable solutions, creating and scaling initiatives that range from local to global. And of course, the most local intervention that you can have is shifting what you eat yourself. These are some awesome food products that I've just found in my past, year of living in New York City, predominantly before the coronavirus took hold. Ag tech and changing our food production, I think this is something that isn't talked about enough. The massive potential is for combining old techniques with new technology. We're seeing a massive resuscitation of old techniques with cover cropping that prevents soil erosion and can sequester a marginal amount of carbon dioxide back into soils. But we're also seeing next generation technologies being applied, including precision fertilizer and pesticide application, so you can use far less of it and get a lot more bang for the buck, and also using robots to harvest crops in a way that is far less exploitive than the current farm labor practices that are being used on conventional farms. We can also mix old with new with respect to our food systems, and I don't think this needs to be an either-or solution of next generation cell or plant-based technology versus traditional meals. I think there's a lot of room for both of these things to sit side by side. And in fact, the Eat Lancet dietary guidelines are vastly compatible with many of the traditional plant-rich cultures that as previous speakers, including Nina and Min, have talked about, involve only a little meat in food to flavor those meals rather than having a big, Porter steak in the center of your plate. Changing the default is also incredibly important, not just in an individual perspective, but an institutional perspective. Anytime food is being procured or shared or catered at an event, we can change it so rather than the default being that, roast beef sandwich, it might be a falafel. And if we outnumber those options, people still have the full amount of choices, but we've nudged them all in a further direction of making plant-based the default. NYC also has a Meatless Mondays initiative with an emphasis on replacing meat with plant protein, and this included a specific call to the climate benefits of reducing meat consumption. The One NYC Green New Deal for the City of New York also has a plan to reduce the city's red meat purchases by 50% and phasing out the purchase of all processed meat in schools, government, and hospitals, which is a known carcinogen. We can also have more science-based guidelines that Canada, for instance, has finally started moving towards. This is a mostly plant-based dietary guideline and can be entirely plant-based. They got industry influence out of the process, which we still have in the United States. It includes drinking plenty of water instead of 3 glasses of milk per day, as little sugar as possible, and eating many whole grains for the benefits of fiber that some of our speakers have touched on earlier today. And it happens to be low emissions, but we can start integrating those criteria more completely in our national dietary guidelines. I also do want to mention that I do think that animal industry is potentially the next frontier for divestment in the way that fossil fuel divestment has really taken hold in the past decade. And I think it's an incredibly urgent issue because countries need to be doing far more to reach their less than 2 degrees of warming under their nationally determined contributions for the Paris Agreement. And that includes the United States now that we're back in it. The beauty of the nationally determined contributions in the Paris Agreement is countries get to pick their own. So if countries feel like they can make far more progress on reducing retail waste than changing diets because, say, that country doesn't have a very meat-rich food system, then they have the freedom and the ability to include those in their nationally determined contributions. But right now, changing diets and largely changing agricultural production is not being mentioned in any of the nationally determined contributions, and that absolutely needs to change. So with that, I'm going to leave up my screen. You can reach me at Matthew Hayek at NYU or follow my handle at Matthew Hayek on Twitter, and I'm happy to take a question if we have time for it.
Matthew, that was tremendous, jam-packed. I really admire how you are so rigorous in your research and you are translating it into action. And really, that's the theme of this conference. You're a perfect fit for our design ethos here. We're really trying to figure out how to become food systems change makers based on evidence, and you're a trailblazer in that respect. So thank you. We are going to go to a break. We have a lot of great questions. I thought I would just ask one question because
absolutely, and I can try.
We haven't talked about big food that much today. What role does big food play? How do they change their supply chains, their product mixes, to actually be to be positive contributors to this transition?
I think it is absolutely essential that big food makes a contribution. I think big food right now is going towards the carbon sequestration route, however, before they've even fully addressed the carbon emissions, which is a downfall of a lot of fossil fuel and other companies as well. I think we need to be getting closer to gross zero before we start talking about getting close to net negative. And I think it's absolutely important for multinational corporations that don't respect the national boundaries, or don't have the same national boundaries, rather, that countries are applying to their nationally determined contributions.
So we as eaters should as eaters really be calling out these companies and their products to be measuring emissions and reporting emissions and creating more transparency about the current emissions of their product portfolios.
Absolutely, that transparency is crucial, especially as companies lobby against that transparency.
Yeah. Well, this has been fantastic. We could go on, I'm sure, all afternoon with your research. We hope to have you back, Matthew.
Great.
Well, thanks for participating, and we will let everyone have a stretch break, a much needed and deserved stretch break.
Well, I was going to mention we do have a little bit more time if Matt wanted to answer a couple more questions. Just a few minutes.
Oh, you just changed the schedule a little bit?
Yeah, we're adjusting a few things on our end because I know a lot of people would love to hear more from Matt. But
okay. Fine.
Okay, so I guess folks can take an optional break if they want to.
All right. Well, let's see. I'm looking over here for some other questions. I have to kind of scroll up on the. Let's see. Here's one. Do you think it would be best to have government regulations when it comes to have big companies shift to more plant-based diets, or should big food companies be the first one to make a move to help the government?
I think that there's a lot we can do before regulations, and that mainly consists of changing incentives, because as previous speakers have mentioned, our incentives are largely towards commodity crops and animal sourced foods. Most of those commodity crops go, by the way, including monocultures, going to feed and raise those animals for animal sourced foods. So I think that government certainly has a role to play. I think the strongest policy is actually always in public-private partnership when the two are working in tandem, rather than a purely laissez-faire or nanny state framework.
Dr. David Katz in his breakout room was sharing, somebody asked him, if you had one wish that you could bestow upon human beings, what would it be? And he said, to develop the discernment to be able to tell truth from misinformation or disinformation. And your comment about the water consumption around almond production was so key, because you see, to your point about how much lobbying goes on and how much influence and advertising, what sources of information do you look to and trust these days as both a scientist and an eater?
Yeah, that's a fantastic question. And I think there are two resources that are very accessible, even though they may be a little number heavy. They try to break it down as best as they can, is Our World in Data, who I follow not only for food and environment, but coronavirus news as well. They're a fantastic organization bringing transparency to a bunch of contentious topics, as well as the World Resources Institute, who takes a very data-driven approach, and especially Richard Waite and Tim Serchinger, Tim, who's a professor at Princeton, really lead a lot of their initiatives around food systems. And as my colleague Cecil, who is attending the session, World Resources Institute also created the Cool Food Pledge that Cecil, he claims but I might debate him, was responsible for initiate NYU adopting the Cool Food Pledge, which seeks to adopt a 25% reduction in food-related greenhouse gas emissions by the year 2030. So the World Resources Institute Cool Food Pledge is not only informed by science, but tries to create tangible action around it.
Thank you. And maybe one last question about the de-investment, because that's such a interesting leverage point.
Yeah.
It strikes me that some of the very large agriculture companies are privately held. Probably Cargill is the largest privately held corporation in the world, and they're a major owner of industrial farmed animals. How do we, either as asset holders, or how do we influence asset holders to take that journey?
I think that that's a fantastic question. And I think that asset holders, even if they don't have ESG, that is environmental, social, and governance standards, material and reputational risk are massive to asset holders. And for publicly traded companies, including Tyson's parent company, I think that you can really get to the public shareholder and do a lot of shareholder advocacy, whether they're a person or institution, around saying, like, get these companies to clean up their act. But increasingly, I'm at large universities, and large universities have endowments, as do, there are state pensions, and private equity is becoming a much larger part of those endowments and pensions as well. So we need more transparency with respect to the private holdings, and get our public and civil institutions to be far more transparent and accountable to the environmental harm that their assets are causing.
You're painting a wonderful, image of these different leverage points in different parts of the system that all need to be moved together and all need to be pressured in concert. And I think, as I think about teaching food systems innovation and entrepreneurship, or systems entrepreneurship, I think about how do we begin to coordinate those levers, the movements of the levers. And I think this symposium is a wonderful place for that kind of thinking and discipline to begin. So Matthew Hayek, thank you so much for being with us.